Okay. So this is kind of the prompt that I recommend just because it'll just simplify the interface quite a bit. But I'm gonna go ahead and paste in a more complicated example. And I've got a smiley face prompt. That link that I posted in the channel will kind of break down a bunch of the things you can do. Just the pure raw IRB is fine for everything we're going to do. Okay, so let's start talking about some Ruby. Use native types. I use that sort of loosely because Ruby has types. It is a dynamically typed language, but there are types within it. But there's also this concept of everything is an object. So in Ruby, we don't have null, we have nil, which is basically the same thing. But it's actually an object too, which means you can call methods on it. So I can call one of the methods that's available on nil is .nil. And that's also available on something like a string. So the string is not nil, that returns false, but nil returns true. So there's some similar methods like .empty, which that blows up because nil doesn't have that method defined on it. It doesn't respond to it. But hello, the string, would have that method. We can call toS on nil, which converts it to a string, which the string representation of nothing would be an empty string. And then we can call .empty on that string, which is true. But we couldn't call .empty on nil directly because nil has a set of methods that it responds to. Strings have a set of methods that they respond to. Some of those methods are like .nil. Both of them respond to because they've been defined on both. And the kind of responses that you would expect sort of come out of those. You can't add nil to one. You can't, plus is not a method. See right here, undefined method plus for nil class. It's not a method that nil responds to. So most of the time you're going to run into nil. It's going to be something that's passed in to a method, and you're going to end up with this no method error, undefined method plus, and it's actually going to be because of a variable you tried to do something with was actually set to nil. So I've set name to nil, and then I tried calling length on name. And then again with an actual name. So you're gonna end up with, as you're working through stuff, you're gonna end up with this no method error, undefined method length, or undefined method plus on nil class. That means that the thing you were calling a method on is actually set to nil at that time. So that's kind of stepping back up and looking for where that was assigned is kind of the next step for what you need to do when you start seeing these no method errors. All right. Let's do some more with numbers. So numbers in Ruby, kind of just standard, just typing them in, do basic math. Out. much going on. So all the basic math operations that you would expect are there. Do multiplication using the asterisk. Integer division using slash. So when I do 10 divided by 3, I get 3 with no remainder or anything. So it's integer division because my integers, I was using integers to start with, and so the result's going to be integers. So again, with no remainder. You use the modulo, to get the remainder value. And then if either of the initial values in the operation are floating point, I'll get a floating point result. Same with if they were both. So there's nothing, you don't specify like I want to opt into floating point results. It's kind of based off the precision of the math problem that it was given. So if the precision that you give it is just 2 integers, it's going to do integer division. If the precision you give it has any floats in it, it's going to do floating precision results. So you can also do exponentials with double star. So okay. Do we need a questions thread? Will you guys chime in? I'm kind of watching Slack while I'm doing this, but again, I'm brand new at this, so if anyone wants to pop in and add questions to the thread that Andrew and Michael just set up. Cool, thank you, Taylor. I appreciate it. Okay, so far we've kind of, the only real conversion that we've done here with this math problem so far is that we've caused some floating point results out of integers. So when this 10 divided by 3.0 was partially an integer, partially a floating point, we did get a floating point result, and that's kind of like a typecasting in a way, but we can do that more literally like we did with nil earlier, and we can say like 256. So that's the integer, 250
Yeah, we can see you, Matt.
Yep,
Alright,
sounds like
thanks.
you're back.
Cool. So just pay attention to the output here on this. On here, when I type 256, 256 came out. Here, when I call 2s, I now have a string. So we call that dot 2s directly on an integer, like a plain integer that I just typed in. So 1, 2, 3, 4, 5, plain integer. Let's see if it doesn't have a dot length method. But it has an abs method, which is absolute value. So if I type 1, 2, 3, 4, 5, the negative, we get the same result. If I type in parentheses, and then abs on that, I'm going to get 7. So there's a bunch of methods that all of these things respond to. Everything in Ruby is an object, and they're going to have methods defined. The Ruby, you pull up the Ruby documentation. So here's a link to RubyDoc. The documentation is split up into core and standard. Core is kind of like the most critical features of Ruby. That's where a lot of your things that you would consider kind of primitive types and kind of the building blocks of the language, like array, string, integer, those things are going to exist in core, where standard is kind of additions to that core that make things a little bit nicer. So you get into like interactions with the file system and some more advanced math and stuff like that. Sometimes you'll be working with Ruby and you need to use something that you know is part of Ruby, but you have to require it in order to use it. That's because it's coming from standard library instead of core library, which is sort of auto-required whenever Ruby's running. As you get into Rails just kind of auto-requires everything, so you don't have to worry about it as much. But Ruby docs, you can kind of poke around to different things like get a direct link to integer here. And on the left, you'll see like a bunch of the methods that are defined on integer, like 2s and abs. Okay, let's get some a little bit more advanced uses. Nightmare scenario. Did it freeze again?
You're back again.
No, you're fine.
Okay, so especially if you're doing like money math where this stuff matters, that trailing one is a problem with floating point precision. And it's pretty much never a good idea to just do basic floating point math in any language, let alone Ruby. For that, I always recommend using big decimal. And that's something from the sort of standard library that we're going to have to actually require into our IRB session using the require keyword. So I just type in require and then pass it the name of the library that I'm trying to require. And now I can actually set up big decimal. I know a lot of you guys are coming from JavaScript. This floating point like precision thing is a huge problem in JavaScript as well. For basic math like this, where we're just using addition and subtraction, I generally just like convert dollar amounts to cents instead of using fractions. So it'd be like 103 minus 42, and then do the conversion back. But But when you start dealing with percentages, if you're building like a financial calculator that has to extrapolate percents and do a bunch of multiplication against money math, it starts to become a huge problem. So big decimal will allow us to get around that by opting into like a more memory intensive but more precise representation of these values. So with big decimal, I'm kind of instantiating big decimal objects here by passing in the string value of the floats that I want to represent. You can see the end result there is this like scientific number. It's an ultra precise representation of 0.61 basically, and I can call 2f on that and get my float that is the one that I expect rather than the floating point version that was the result before, which had the trailing one. There's also stuff like the math library, which I can access. So math is just this namespace in Ruby, and by going into it to get pi is a constant in there. I can also access things like square root directly in there. Floats can be converted to ints. Rand is kind of just generally available in Ruby. So that's going to give me random numbers between 0.0 and 0 and 1. But I can opt into like a different distribution, so I can go from 0 to 100. I can also do things like rounding. Using like floor and seal. So you'll see a lot of, like we did this one earlier, this method with a question mark. Technically question marks are valid on any Ruby method. You can just, it's just one of the valid characters, but there's a best practice for them that they should always return true or false. So that this is called a predicate method by people, and there's a bunch of them, and you'll find times where you'll want to write them. Here we have a floating point, 125.1234, that I'm calling dot integer on. And it's important that you, when you say the method, you gotta like inflect like it's a dot integer, like it's a question. Here, calling it directly on an integer, and it's true. So these predicate methods are always returning true or false. Integers have 0 method available on them. Okay. Strings, we're moving to strings now. So there's the literal string syntax of like double quotes. This is a string that can handle interpolation. It can it's kind of the full complete string. You can also use a string with a single quote, like this. So the difference is in how you can interact with them. So I'm going to go ahead and set the string Ruby to the variable language. Call length on it. I can also call size on it. Size and length are somewhat interchangeable. They basically do the same thing. They're methods that you can call on things like strings, like arrays. Typically, it's more common to see length used on strings and then size used on some collections like array. So if I had an array of things calling size on it, even though they both respond to length and size, it's just kind of like a community thing to call length on fixed objects like strings and size on collections to get basically the same concept out of it. Now we're going to see with double quotes, I can use interpolation here. So using that hashtag and the curly braces, I'm able to interpolate Ruby code. So it's evaluating the language variable into the string. If I had single quotes, it wouldn't do that. So now it's doing this like escaped character and just kind of spitting out exactly what I typed in. Single quotes will not be parsed and have interpolation operated on. But they can do concatenation like we did earlier. So this is still valid with both double quotes and single quotes. It's really the big difference is the interpolation, which single quoted strings are slightly lighter weight, like memory-wise, performance-wise. But I tend to opt always for double quotes just as a rule, because they're always going to be able to do whatever I want to do with them. But you'll see code bases where the difference between the quotes is taken into account. So it'll be always single quoted unless it needs interpolation. Strings have other methods, so we can call upcase. Notice this does not mutate the language variable, it's just returning the value. So if I have a mixed case string here, I could call downcase on it, and the return value is going to be everything downcased. I didn't mutate the string itself. Here, I'm using gsub to sub out all of the U's in this string with A's. I'm going to do that again on a variable. Okay, so the return of that is abracadabra. Test is still abracadabra. But if I use gsub with a bang, with an exclamation mark, the return value is abracadabra, but I've also mutated the variable. In Ruby's standard library and core library, the bang method is often going to indicate mutation. In Rails, which we'll get to in later classes, bang generally means that it's just a dangerous operation that can throw an exception. But in the Ruby kind of core library, it's generally going to mean that you are going to mutate a variable. So test is now forever changed to abracadabra by using gsub. I would avoid these sort of bang methods as much as possible, because generally you want to, if I wanted a new way to capture that, generally I'm just going to try to avoid mutation whenever possible. Bang on everything, Carlos. There's also symbols, which you'll see a lot when you start interacting with hashes and a lot of Rails stuff. They are like really small strings. They act as sort of low memory usage strings. They are kind of permanent. You can't mutate them anyway. They respond to a subset of the same methods that strings have. They're used a lot to reference keys in more complicated structures like a hash, or to talk about to kind of like capture method names. If you want to pass the concept of a method name around, the symbol is used a lot to represent like length. Here it's a symbol, but if I wanted to kind of hold on to the concept of length and then later call it on something, I would generally use a symbol for that. It's a pretty complicated thing that we'll get to more later, but symbols are another kind of primitive type that you can utilize. Ruby also has booleans. True, it's just the bare word. False, with booleans comes all of the operations like or. So true or false would result to true, false or true, result to true, false or false, false. True and false. True. Hopefully you guys cannot hear my child screaming. So you also get like the equality comparisons, like 5 equals 5, that's going to be true. 5 equals 1. False. If you're coming from JavaScript, you probably have concept of the triple equals. In Ruby, it means something different, and generally you want double equals. Triple equals is for a very unique case. So it's kind of like flip-flop, where I feel like I always am opting for triple equals in JavaScript. In Ruby, it's double equals that you mostly want. Do it with strings. Do not equal. Less than. Greater than. Pretty much all the operations you're used to. Most of this stuff is pretty straightforward. It's not really Ruby unique yet. Here's one that's a little bit weirder. So we're going to look at memoization using these Boolean operators. So you've probably seen something like sum equals 5, sum plus equals 1. So this is mutation that I'm doing here. I'm saying sum is going to be equal to the result of sum plus 1. So it's kind of like shorthand for that. Now let's look at this in the context of a Boolean operator like OR. So I have a name of Jane, and now I'm going to say I want to return the value of name or equals Sam. So the result of that is Jane. My name is Jane right now. New name is this undefined local variable. If I do new name or equals Sam, I'm going to get the result Sam, because new name doesn't exist. Sam does, but now let's look at what new name is. New name is now assigned the value of Sam. So this is like we're saying new name or new name equals Sam. So if new name already had a value, it's just going to return that value. And that's what happened with name or equals Sam. We had already assigned name to Jane, so we're just going to return Jane, and name is going to stay Jane. But if name was nil or undefined, it's going to be assigned to Sam, and we're going to return Sam. That is because we're going to first check, is name there? If not, assign it to this memwise value. Okay, the questions thread. Looks like we're good, question-wise. Let's start into some control flow. So we're just going to do some basic looks at control flow, like if-else statements. So I have this variable test, and test length is less than 5. Return the value short. Here I'm using else if, so it's one word, it's a keyword in Ruby. It stands for else if someone just didn't want to type that E and that space when they're creating Ruby. I think it's one of the goofier looking things in Ruby, but it's not too bad. So that one requires another condition because it's an else if. We'll call that medium. And here's our else. We're going to use the end keyword here to close out this conditional. So we do need to kind of close out this block of context that's opened by the if block. Now we have that, and the result is medium because lambda is 6 characters. We can also do ternaries, which are sort of inline if-else's. So here we've got some, I'm going to do this again with like parentheses to sort of show a little bit. Got something we're evaluating. And then the question mark starts the ternary. As far as the indentation goes, I just type space a lot. That's how I do to make it look good. I'm not doing any magic IRC things to get that. I just type space, just so it wouldn't look crazy to you guys. So that question mark kicks off the ternary, and then on the left side of the ternary is what will happen if an evaluate is true. On the right is what will happen if an evaluate is false. This can start getting a little weird, like if you have predicate method that you're using, and then a question mark to open the ternary, and then you're returning symbols, you can see that suddenly this starts looking pretty crazy. So just be aware of the readability when you're using ternaries. If you're using predicate methods and returning symbols, sometimes it's probably just better to go with the if-else block, because this kind of this like symbol soup and double questions gets a little weird. Ruby's got a special keyword called unless that basically performs an if not. So I'm going to do this not there. Okay, so basically, if it's less than 4, if it's not less than 5, it's going to be long. But we can avoid the if not by using unless. So unless test.length is less than 5, do this. Is kind of how to read that. So unless this is true, do this. And do this is whatever's inside the block that you're passing. Unless can fit in right with everything else you'd expect, so you can do an unless else type combination. Where it can be really useful instead of if not is when you start using what are called hanging conditionals, where you can actually do a one-line hanging conditional. So I want to do this 5 plus 5 unless test dot length is less than 5. So test dot length, just as a reminder, is 6 right now. So I want to add 5 plus 5 unless test dot length is greater than 5. And now the end result of that operation is nil, because I did not run the 5 plus 5, because test dot length, that condition did not pass, so the 5 plus 5 was never run. This is a trailing conditional that allows you to do kind of like set up some work and then only run it based off of this conditional at the end. So I get the string hello world because test.length is greater than 5 in this case. So can switch that for an if. So if and unless can be used in this sort of hanging conditional format. This is how, whenever I'm using unless, it's generally in this format. I don't typically start off a block with it. I think it reads really well when you're reading code when it's used as a hanging conditional. So I'm going to do this unless this condition. Whereas unless this condition, do this is kind of like, sometimes I have to think about like, okay, if not, what would this be? I like it in this format. I'm not as big a fan of unless in this format because I feel like my brain is like stuck doing a translation there to figure out what's going on. But both are valid. It's a when I first started Ruby years ago, that was kind of one of the things that I was like, oh, there's some less things. Just exit out real quick. All right, we're ready for arrays. Arrays are basically what you'd expect coming from something like JavaScript. They're just little collections. We use square brackets to define a literal array. So here is a literal array of languages. Each value in this array is just a simple string. I now have this array, and like I said earlier, arrays themselves respond to methods. So it has a size, which is 6. It has that length method as well, which is again going to be the same thing. So just like with integers or strings, the Ruby core documentation will kind of list all of the methods that are available on it. Up here we've instantiated it by just kind of literally typing it. You can also, array is a class that you can call new on, just like anything else. Values that it takes are a little weird compared to typing it out literally, but I've just instantiated a new array, told it it's going to have 2 values and they're both going to be A. Some of the more useful methods on array are things like join, which I can tell it to join everything, all the strings inside of it, using the pipe operator. And I have a string that's just a single string that's all of those values joined using pipe. And tell it to join them using a comma and a space. Now I have a string where they're all kind of split out. Call dot length on that string. So join's a pretty useful method for arrays. We can also call sort. Ruby's going to have a built-in sort that will run on here. It uses, when you call sort, it's going to use a comparison of whatever the type of objects are inside of there. Since they're strings, Ruby has a built-in comparator for those. So it's going to go alphabetical. It's kind of how strings are going to end up being sorted. It also has the include predicate, so I can ask it if it includes Ruby. It does. I can ask it if it includes Elm. It does not. So also a bunch of kind of helper methods to get the first element, get the last element. You can use bracket syntax. So it's 0 indexed. You get just kind of look at this whole array. And so at the 0 index is Ruby, at 1 is JavaScript. Using -1 will get us Go. Using -2 will give us Java. So if we use negative numbers in this bracket syntax, we're going to start at the back, and 0 is kind of like this holding point out here. So -1, -2, -3, as opposed to 0 being the initial spot. There's also a bunch of notation methods like pop. So this just popped off Go. If I look at my languages array, Go is now gone. So I've actually popped popped off that value from the list. If I add elixir using the shovel operator, I've just pushed that onto the edge, on the end of the array. That's this double less than is known as the shovel operator. So I can pop elixir back off. So, and then shovel it on again. You can also use push, which does the same thing. So shovel operator is kind of a unique one, whereas push and pop are sort of like meant to pair together. And we've got on shift. On shift is like a push at the front of the array. So I've pushed crystal into the start of this array. And shift is like pop for the start of the array. So it's taken the first thing out and then shifted everything left. So if we look at languages again, crystal's missing. So unshift and shift work at the start of the array, and push and pop work at the end of the array. Shovel is just kind of a alternate way to do push. Okay, so when I'm saying the word shovel when I'm talking about this operator. Shuffle is something else, and so let's look at languages. If I call shuffle on this array, it's actually just going to randomize it every time. It's just going to sort of mix it up. When I shovel something onto it, that's just, people just kind of named that double less than the shovel operator. And I'm saying shovel. There's probably an emoji for that, but yeah, so shovel versus shuffle, those are two different concepts. Yeah, let's start. Okay, my alarm is going off. It's time for our break. We're gonna take a 15-minute break, unless that's too long. I think I was told that we needed a 15-minute break, so let's go ahead and do that. I'm going to be in Slack, and I will probably just keep this thing open, but I'm going to mute and let you guys all take a break and just rejoin the same video or same chat. And we'll be back at it's 11:10 Mountain, 10 Pacific. 14 minutes. All right, we're gonna get started again. So the next topic we're gonna go over is hashes. Word. So what is a hash? If you're coming from JavaScript, a hash is kind of like a JavaScript object. Each element in a hash is a key value pair. So there's a key that points to a value. There are a couple different syntaxes in Ruby for hashes. Early on, Ruby supported the hash rocket syntax, is what it's referred to as. And then I think it was around Ruby 2, maybe a little earlier, where they introduced the symbol syntax for hashes. And that's kind of become the more dominant way to type out like hash literally type it out. But we're going to go over both because when you get a hash back from Ruby as like a return value or something, you see it printed out, you're going to see it in the hash rocket syntax. And sometimes it's useful to use hash rocket because of the type of keys you're working with. But for the most part, most people use the symbol syntax. So hashes are used as lightweight data objects to pass like bundles of data around instead of passing like a bunch of different attributes as individual variables. Will pass like a big hash. This is super useful in a web application when you need to submit like a form of a bunch of data as JSON. Then we can convert that JSON object to a Ruby hash and work with it in Ruby. So let's make a person. We're going to make Jane. And so Jane is my variable, and I'm just assigning it to a hash that I'm going to open up with curly brace. And the key name, I'm going to use the hash rocket, which is equals greater than. So it just kind of makes this nice little arrow that Rubyists call the hash rocket. I'm going to use comma to separate each of my key value pairs. So, oops. Jane is a software engineer. And her age 30. So I'm going to use a trailing comma here, meaning a comma at after the last thing. That's just that's optional. You don't have to have a trailing comma, but you would need commas between each of the values. So I now have Jane. If you see this result is my Jane object, which is a hash with a name key, a job key, and an age key. This hash I can call methods on, like values, and that's going to return me an array of all of the values. So the Jane Doe, software engineer, and 30 are all of the values that are on this hash. If I call Jane Doe keys, I'll get a list of all the keys, which are name, job, and age. I can access keys using bracket syntax. So I'm going to pass in the key name to the Jane object, like bracket accessor, and I'll get Jane Doe. I'll pass in age, and I get 30. Pretty simple. If you have any questions, please feel free to hit up the questions thread. That's the hash rocket syntax with string keys. Strings aren't the only valid keys you can use in a hash. I can also set up a hash literal with symbol keys. Sorry about that. Looks like I'm back. Okay, so symbols, when they're used as a key in the hash, you can use them as a key with the hash rocket syntax, and it would just look like normal. And then I can access that with the symbol name. I can't access that with the string key name because there is no string key in the John hash. It's a symbol key. Ruby has a special syntax for hashes when you're using symbol keys that allow you to kind of opt out of the hash rocket syntax and use something that looks more like JSON, like a JavaScript object. And you're able to basically flip the style of the symbol to look more like something you'd be used to in other languages. So in this case, name is a symbol, and I'm not using, and by flipping the colon to the opposite side, I don't have to utilize the hash rocket. I just kind of write it out. So John's a product owner, and age is 28. So you can see the output kind of switched it back to the other style with the hash rockets, but we were able to type it in this kind of cleaner, more comfortable style that you're used to if you're doing stuff like JSON. The access still happens with symbols, so if I want to access this, because these keys are actual symbols. So we can get a list of all keys, just like we did before. And I'll just call the values. This list of keys is a list of symbols, as opposed to those strings when we use strings as our keys. We can call to A on a hash. We call it on Jane and John. And what's happening here is our hash is being converted to an array of arrays. So it's a two-dimensional array where the first element in the array is the first key value pair as an array. So when I convert a hash to an array, if I say I'm going to just convert John to an array, to A, and then I'm going to access the first element on that array. It itself is an array of the name key and the John Doe value. So when you convert a hash to an array, it's an array of key value pairs. All right, so that's hashes. We've done kind of a look at all of the sort of primitive types of Ruby, some math and stuff involved. Now we're going to start looking at methods, functions, and blocks, which are kind of like one of the coolest parts of where Ruby kind of shines is with blocks. So methods are defined using the def keyword. We can define a method and then use it later. The return value of the def is the name of the method as a symbol, but the return value of the method when it's called is going to be the last evaluated element. So you can do an explicit return where you type the return keyword, but for the most part, Ruby is based off of implicit returns. I'm going to go ahead and just type this out real quick. Exit, and then IRB again. So I'm starting with a fresh IRB session. I'm just gonna, we don't have any closure, any wrapping around this. I'm just gonna define a method called greet. It's going to take a parameter, an argument called person. In that method, I'm just going to interpolate person to a string. So you see, it returned the symbol greet. That's because when you define a method, the return value of def is greet. This is something you're going to see when you're typing into IRB. You don't really see this return value when you're like writing into a Ruby file. What's important is that we now have, in this context, we have greet defined. And we can call greet with a name. And now it's going to say hello Jane. That's going to be the return value of the greet method. Even though there was no like return specified, it's just whatever was the last thing operated on. So this value is just the result of this operation. You don't need parentheses in Ruby unless like you've got a complex thing where the parentheses are needed to make it intelligible, to disambiguate what's going on. So I can just call greet, no parentheses. I'm going to stick to parentheses for most of the time just so you can kind of understand what's happening in different places, but this is just as valid because the parentheses in this point are, Ruby understands that greet is a method. It understands that the next thing is going to be the argument passed to greet, and we'll just sort of figure it out. So parentheses are mostly optional. That includes when you're defining a method. So I can define a method, do math, and say that its arguments are ABC. I'm going to add A plus B, B plus C, and A plus C. And I'm going to end that method definition. And when I call do math and pass it 2, 6, and 12, the return value of do math is 14. So we added 2 plus 6 on this line right here, and we added 6 plus 12, which is 18. And then the last thing we did was add 2 plus 12, passing 2 to A, 12 to C. The last thing we did is going to be the return value of do math. So all this other work is just kind of lost because we didn't save it anywhere, we didn't do anything with it. It's all kind of hidden. If we needed something, like say, let's do some explicit returns. Right, I'm going to redefine that method. I'm going to say return A plus B. Next line I'll say return B plus C. There's no rule about how many returns I can utilize in here, but as you'll see, if I call that method again with the same values, 2, 6, 12, the result is 8. Because as soon as this return was hit, it returned. It ended operations on the method. So A plus B, 2 plus 6 was the return value. It never made it to these two lines because our explicit return kind of short-circuited anything else happening in there. So in both cases, this is the last line evaluated because this return operation kind of forces this to be the last line. This exits the method. In this case, A plus C was the last line evaluated, and that ended up being the return value. So if we wanted the result of all three of these, we can redefine doMath as returning an array. So I'm just doing the same math that I was before, but now I'm returning a single array. Okay, so that's getting old. I'm back, I think.
Yeah, we can hear you.
Okay, so it's kind of like you just need to understand like how to identify the last line evaluated when you're writing a method and understand what the return value will be. Let's move on to some blocks, which are in Ruby. A block is a closure that can be the code, a functionality. So it's a little context that you can pass around. They're pretty great. Blocks can be wrapped in either curly braces, similar to how hashes are, or in do and end keywords. So there's different people have different rules of when to use curly braces or do end, and for the most part, my rule is like if it's a one-liner, I'm going to use the curly braces. If it's multi-line, I'm going to use do and end. There's also pipes, which allow you to handle variables going into the block. But we're just going to do a quick little block here. Integers have a method called times that will take a block and run it as many times as the integer value. So in this case, it will run it 4 times. It's going to run this block 4 times. And I'm going to, in this block, I'm going to say puts high, which is print out the string high. So for 4 times, print out high. The return value of times is the actual integer, but you can see while it ran, it spit out my print statement as many as 4 times. So you can also do this in the curly brace style. And this is going to run 10 times. Okay, so this, inside this curly brace, inside this do end, it's just this block of code that is being passed to times. And then times is going to call it 10 times. That's how the method times is built. There's a bunch of different methods that accept blocks, and they'll kind of work differently. But let's take an example of we're going to have our Jane hash again. So Jane is a hash. Hashes have a method called fetch, which I can fetch the name. That's another way to access Jane, access the keys of Jane. So if I fetch the location, unlike if I had done location using bracket syntax, it would just return nil. But if I call location with fetch, it's going to blow up because there is no key in chain named location. Fetch takes an alternate block, which lets us provide a fallback value. So I can pass it a block that instead of throwing the exception, which is what happens when the key doesn't exist and you call fetch, throws this exception, key not found. Sorry, I'm reading a question going on. So here I'm providing this block, which is just this fallback value. So I'm passing a block that says if you don't find the key, then run this block instead. And here, instead of blowing up, we're getting our default value. So this is kind of like a completely different use of the block context. And you can run full-on lines of code in here. I can pass and say location failed as a put statement, and then I can return my fallback location. So now I've run the put statement that's in there and gotten Salt Lake City back because this block that was executed has both those behaviors inside of it. So I've got the print statement as well as the fallback value, which is the ultimate return value. When blocks get really cool is when you start using them with enumerable methods like map and each. So enumerable is this ability within it's this kind of mix-in behavior that is available on multiple different types of objects, particularly arrays. It gives it methods to iterate over the collection instead of setting up like a formal for loop. You can just sort of run code that you want to run against each of the elements in the collection. Each is a method that is best used when you want to cause some sort of side effect. When you call each, the return value will be whatever you called each on instead of whatever you were doing in the blocks. When you use map, the return value will be the result of the operations passed to map. So I'm just going to do a real small thing where each, and then I'm going to capture the value being iterated on. So the first time around, this value will be 1. Now plus 1. So the return of this block should be 2, then 3. And the return of this whole operation is still just 1, 2, because each won't actually it doesn't return what you did. It returns the object that it started with. This is opposed to map. The first and second. Oh. So this is an important distinction using each for when there's only kind of, if you don't want this to change, then that means whatever you're doing in here, in order for it to matter to the rest of the code, like this must be some sort of action with a side effect. So you must, like, in order for it to eat, because we ran this block of code and we never saw the results, we never did anything with it, so each kind of didn't make any sense. But if I was doing puts, if I just wanted to print the result of this to screen, I'll get my original array back, I'll get the puts operation, and everything will be good. If I did that with map, the result of puts is actually nil. I ended up with 2 nils in my array that came back. So this is about like what your goal is when you're iterating over stuff. If you want to mutate something, or if you want to get a new collection. So let's go back to our languages from earlier. So we'll have like a nice big array to work with. So this is just a list of programming languages, and I can call .each on it, and notice my list is named languages in the plural, and then I'm going to work with a variable in the block called language. Then I can call .upcase on that individual language, and nothing really happens here. If I do the same thing with map, then I'll return a new array with all of them upcase. Languages is still fine. For my new array, oops. My new array is everything's all caps, so I can set that to a value. Now I have this new array method, a new array variable that's got the result of my map. So the better use case for each is here we've got a good use case for map, where we want this new thing that's everything's capitalized. And we don't really want to change the initial languages. Each didn't really do anything for us. It just kind of we lost all of its work. If we wanted to output each of the language's names, map would actually be kind of a bad example. So if we wanted to fix language, now we end up with a return value of all these nils. We got the output that we wanted. We got each of those printed to screen, but here each is kind of the better example, better use case for doing something with a side effect like printing to screen. So now we've got the same array we started with. We could chain off of that. We could keep working with that, and we got the destructive output, the printing to screen that we wanted. That's each in map. They iterate over the thing and apply the block that you want. You can chain those together. So we wanted to map over the array and create a new array that upcases each language. Look at where the result of this is an array. So we can just call dot each on this and puts each language. So we're calling on languages, which is this array right here. We're calling map, and we're saying upcase each language. This is going to return this new array
with capitalized all caps languages. And then on that array, we're going to call .each and puts each value, print them over the screen. .each would then return the array it started with, which is the capitalized array. Okay, so we printed all the capitalized values and we ultimately returned this all caps array. Languages is unchanged. That's each and that. Ruby has a range type that you can set up, like say 1, 5. So that's a range. You can actually, these are also enumerable. So I can do each number that gets passed in, I can just put some on. So this range 1.5 is the range of values 1 through 5. With 3 dots, it's non-inclusive of the end. So with 2 dots, it's a range that's inclusive of the last value. With 3 dots, it's saying go up to this but stop. So it's 1 through 4 and 1 through 5. Ranges are pretty useful when you want to do something like I'm going to copy and paste some fizz buzz in here. So I've got this. Got this fizz buzz of 1 through 50, and then I'm passing it a block, and this is just straightforward conditional with, if you're familiar with fizz buzz, it's like, if it's divisible by 5 and 3, then you put fizz buzz. If it's divisible by just 5, you put fizz. If it's divisible by 3, you put buzz. Otherwise, you put the number. So this little block, it's going to go, it's going to run through each of the numbers, 1 through 50, with 50 included, and run this block on each of those numbers, which ends up with this 1, 2 buzz for the fizz, this nonsense that is fizz buzz. So ranges take are also enumerable, so we can call each simply shown, but you can also call map. So we do a quick way to build more. If I want an array of the number is 100, I can build one with that. I'll just return each number from that, and now I have an array full of stuff. Am I still muffled? So map and each are about iterating over something and operating on each element. There's other enumerable methods like select and reject that are about sort of filtering the elements based off conditions. So let's take a look at our languages array again. And what we want to do is select any language where the length of the language is greater than 5. So I'm going to call select on that array and pass the language into the block. And if the result of the block is true, the resulting array, like it'll be selected for the output array. So there's only 3 languages in this array that the length is greater than 5. And it returned a new array with those 3 because it selects, it filters, it keeps everything that returns true in this block. So if I just said true in here, if I just return true in this block, it would just select the whole array. If I give a condition like m.length is greater than 7, there's only one element in that array that would be selected for the new array, because only JavaScript has language with that length. You can also, the inverse of select is reject, which is the opposite. It will keep anything that evaluates to false and reject anything that evaluates to true. So here we've got the original languages array minus JavaScript because I've rejected anything that's true. If I just do a straight up true in here, it'll always evaluate to true. Now I'm just going to reject everything because that's the only case that can happen. And if I do 9.5, I'll be down to Java then Swift because I'm rejecting anything that evaluates to true. Let's select and reject. It's going to reduce, which is a sort of functional approach to accumulating a value. So it takes a collection and boils it down. The classic example of reduce is summing an array of values. We can do this using, let me just set up a counts array. I also could have made that array by because it's only 1 through 5, kind of easier to type it out manually, but that range is super useful for setting up large arrays of numbers. So I have this counts array. What I want to do is get the total of all values in this array. So I'm going to reduce it, starting with 0. I'm going to pass it 2 variables. So these pipes within a block are variables that will go under the block. I'm going to say sum plus count. And that results in 50. We do this again in the do end style syntax. Okay, so what's happening here is we are iterating over each element in this counts, just like we did with each, or not. But we're also tracking the return value and reintroducing that return value. So when sum plus count occurs, so this sum to start is the 0 that we've provided. The first element going into this block is some starting point, whereas count is each position, each turn, it's the different positions on it. So what's happening is at first it's saying 0 plus 1, and that's my return value. And that is now the sum on the next iteration. So now I'm going to do 1 plus 2, which is the current count on my second iteration. This 3 is now their sum on the next iteration, along with 3 at that position, so that's just going to happen. So now 6 is going to be the sum, and it's going to be added to 4, And now 10 is going to be the sum. It's going to be rounded to 5. So to make this a little bit more explicit, we can do do an explicit return. Oh, not an explicit return. You know. Okay, so this is one of the more complicated concepts we're going to be dealing with today. This is the most complicated thing in time about today. So, are there any questions about how reduce works and what reduce is? The fact that I named that value sum is just because I was doing summation. There's other reasons why you would use reduce. I'm going to do one next that involves strings. And let's see here. So I'm going to reduce this. And the starting point is going to be an empty string instead of 0. Because I'm not interested in starting at 0 and doing addition on top of it. I'm interested in accumulating a string of languages. So this is me implementing join, basically. Let's do a join real quick. So this creates one string with spaces in between each word in it. And then kind of manually implement this join, starting with an empty string is the accumulator. And then for each iteration of the language. And now I'm going to return an interpolation of the accumulator, space, and the current language. So this one's on because I started with the space. This is because on the first iteration, what I'm doing is I'm accumulating an empty string. The accumulator at that point is an empty string. And then the line at that point is elixir. And my interpolation looks like this. So that's empty string plus a white space is line. And I end up with this, which is not an ideal solution for join. I don't want this space at the beginning. I want join to kind of perform like this. Reduce doesn't require a value passed in for the starting accumulator. So you can avoid that by just not passing an initial value. And it won't happen. That's because when you don't pass in an initial value, the first iteration will sort of just skip, and it'll start with the first element as the accumulator. So I think the first iteration will just not run well. You can do that with the cancel array from earlier. And I can do that sum again, but without the 0. And you work exactly as you expect. If you kind of like nothing is your starting point, like 0 or an empty string, then often it's better to just not introduce that starting value. But if you wanted to get your counts based off an initial value of 5, then you'd want to have to be able to pass that in. So if you don't need to specify an initial value because the starting, like you don't need a starting point, then you don't have to pass it to reduce. You can just kind of do it reduce. Sum is a pretty classic example of something that you wouldn't necessarily want to pass in that 0 for. It doesn't really hurt. This example of how we were doing a join operation, this is actually hurt by the fact that we passed in an initial value. Okay, so that's reduce, and that is the end of our topics for the day. Any questions? There's a, you guys probably know more about this than I do, but there's a RoRX help channel and a RoRX after hours channel. And that I will try to pay attention to the RoRX help throughout the day, doing some other stuff going on, but incorporating this. This is just sort of broad introduction to Ruby. We'll start getting into more object-oriented programming and stuff like that, and then eventually tackle some web applications. And hopefully, the course goes well. Then in the RoRX or RoRX help, I'll be around for a bit. Some other people are manning that too, I think. Thanks for your time today. There isn't really a project since we were just kind of typing this stuff into IRB. There's not really a project today. It's more of an introductory thing. There'll be something to deliver on the other days, I believe. At least most of them. But today there's not like an assignment to turn in. Okay, I lied. I'm lying. Well, sorry. What I meant was like there is still like you still have like a student project today. There still is the student portion, which has a readme project. I just mean there's nothing like from this particular session you just did with me that has like something determinate.